Question number 13, we're trying to find the volume of each of the solids and arrange them from smallest to largest. Looking at our values, our problems, we see that we have a rectangular prism, a sphere, a cylinder, and a cone, all of which we have volume formulas for from our formula sheet. As we can see here, volume equals length, width, and height, which we all have. Answer problem A. Volume equals 4/3 pi r cubed. We're given the diameter here to be 10, meaning that our radius value is equal to 5. For C, we have the volume equals pi r squared h. We're given the height. Once again, we see the diameter is 8, meaning our radius is equal to 4. And lastly, for D, we're given volume equals 1/3 pi r squared h. We're given our diameter is equal to 16, which means that our radius is equal to 8. We don't know the height, though, here, so let's take a moment and see what we can do about this. Redrawing this scenario, we see that we have a radius of 8, a slant height of 10, and our height being unknown. To help us find for the height value, we're going to use the Pythagorean theorem, which setup is 10 squared is equal to h squared plus 8 squared, or 100 equals h squared plus 64. Solving this down for h, we get h is equal to 36. Now we have all the information we need in each of these scenarios to substitute our values into our formula, which we can see here. Putting these into the calculator, we get our answers and we see our 4 volumes clearly listed here. Arranging these from smallest to largest, we see that A is the smallest at 140 centimeters cubed. C is the next smallest at 351.858 centimeters cubed. D is the next smallest, largest rather, 402.124. And lastly, B being our largest volume of the sphere. Question number 14 and 15, we're finding the area of a sector and arc length. Area of a sector, we've already discussed the proportion we're going to use for this. For area of a sector, we're going to set up a ratio of degrees to the ratio of areas, where degrees of the sector over the full 360 set equal to the area of the sector over the full area pi r squared. We'll set up the ratio of degrees, 360 degrees in a full circle. We see the degrees given is 65. Now we'll set up the ratio of areas, the area formula for a circle being pi r squared. In this case, we have the radius of 4. And we are actually asked to find the area of the shaded sector, so area of the sector is our unknown value in the proportion. From here, we just simply cross multiply and then divide by 360, giving us an answer of 9.076 inches squared. For question number 15, we're finding the length of arc B, so we're finding this distance. Very similar to our proportion that we set up for area, we have to set up a proportion using instead the circumference of a circle. Let's take a look at that. Our proportion is once again a ratio of degrees, the degrees in our circle, and our portion of the circle over the full 360 degrees we know are in a circle, set equal to the arc length, which is the crust, the piece of the outside of the circle that we're looking for, over the total distance around a circle, which is in fact the circumference, which the formula is 2 pi r. So ratio of degrees to ratio of circumferences. If you notice, this is very similar to our ratio of degrees to ratio of areas, except here we're looking for the area of a circle. Here we're comparing it to the distance around a circle or the circumference. Back to our problem. We'll set up the ratio of degrees. We know 360 degrees in a circle. Here are 150 degrees. For the ratio of circumferences, we know 2 pi r is the distance around the circle, radius here being 18, and we are asked to find the length of the arc, so that is going to be our unknown value x in the proportion. Once again, we'll cross multiply and then divide by 360. This gives us an answer that x is equal to 47.124 inches. The arc length is 47.12 inches long. Number 16, yet again, another arc length problem. We're finding the length of arc AB. So we'll set up a very similar proportion. In this problem, we are given that the degrees are 120 and our radius is equal to 10. And once again, we're finding our arc length value. So that is going to be our unknown. We will cross multiply and divide by 360, very similar to number 16. Giving us an answer of 20.949 feet for our arc length.